Okay, we're picking up the second part of 5.3 video for pre-calc. We're on example 4. So what we're going to do is first notice that all of these values that you are going to be finding the sine, cosine, and cotangent of, these are special right triangle values. So pi over 3 right away, think if you want 60 degrees, this, think 45 degrees. I shouldn't say equals, it doesn't equal it, but pi over 3 equals it. Pi over 6 is a 30-degree angle. And so you just need to know those from example 3 right away. You just need to recognize them. Okay, so that means if you want, obviously you could just look at the problems we've already done to find these answers, but let's just pretend like those aren't up there, and this is how you would solve these. You would draw your 90-degree angle. Here's your 30, which is your pi over 6, and here is your 60, which is your pi over 3. So we're dealing right here with this angle. We want pi over 3. The shortest side is always opposite the 30, so I have 1, the hypotenuse is 2, the other leg is radical 3. And so sine of 30 is opposite over hypotenuse, so this is radical 3 over 2. Cosine is pi over 4. That would be from your 45 right triangle. So these two angles are equal, and we have, for that, we put our 1 and 1, and our hypotenuse is radical 2. So cosine is going to be adjacent over hypotenuse, so we have 1 over radical 2. And then cotangent is, remember, the opposite of tangent. So, you know, tangent is opposite over adjacent. So then cotangent is adjacent over opposite. It is the reciprocal. And so you're going to go back over here to this angle right here, which is 30, and we want adjacent over opposite, so this is radical 3. So those are your answers. And that's how you can use your special right triangles to find those. I want to just point out that you've probably picked up on that, but we are not rationalizing our denominators on these problems. So you do not need to rationalize denominators in these types of situations. Moving on, example 5. Find the acute angle that satisfies the given equation. So I'm trying to find theta here. I know the theta, the numbers involved in theta are radical 3 and 2. So right away I think of a 30, 60, 90 triangle, because radical 3 and 2 are all in a 30, 60, 90 degree triangle. So I go back over here and I say, all right, I have that triangle already drawn right there. So the sine is opposite over hypotenuse. So my hypotenuse is 2, and the opposite has to be radical 3. And so the angle, we're either looking at a 30 or a 60, but it's the 60-degree angle that will give me the radical 3 over 2. So theta here would be 60 degrees, or you could say pi over 3. That would be your answer there. And you can just reason that out. Remember, if we were using a calculator here, we would say the sine inverse of radical 3 over 2 is theta. We would use the inverse function. Over here, b, tangent of theta is 1. And so again, that, if I'm going to have opposite over adjacent, which is tangent, and I want that to equal 1, then I know these two have to be the same, right? The opposite side and the adjacent side both have to be the same number, and then it would simplify to 1. Therefore, I'm using a 45, 45, 90 special right triangle, and I have one of those drawn right there. So the tangent of theta would have to be 45 degrees. I'm sorry, theta would have to be 45 degrees, which is pi over 4. Because the only way to get tangent equal to 1 is your opposite and your adjacent have to be equal to each other, which makes it an isosceles triangle. Secant of theta is 2. So the number 2 doesn't really show up in a 45-45, but it does show up in a 30-60. And so if I want secant, secant is 1 over cosine. And so if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And so if I have 2, that means basically I would have 2 over 1. And so going over to my 30, 60, 90 right triangle over here, 2 over 1. My hypotenuse is 2, the leg is 1, so I would need theta to be this 60-degree angle. So I have adjacent. So we're here at 60 degrees, which is pi over 3. So that's just a matter of reasoning them out, because I don't want you to use a calculator for those when you see these numbers that are a part of our special right triangles. Finally, example 4, a ladder is extended to reach the top floor of an 84-foot tall burning building. The firefighter sees someone who needs rescuing in a window 8 feet below the roof. So let's draw this. We have a 84-foot building right here. That's 84 feet tall. They're using a ladder, so it's going to lean. That will give us our 90-degree angle. The firefighter sees someone who needs rescuing 8 feet below. So we're right here at 76. How far should the ladder be extended to reach the window if the ladder must be placed at the optimum operating angle of 60 degrees? So here's my ladder. And we need this angle has to be 60 degrees. This height is 76. The question is, how far should the ladder be extended? So this here is the ladder. How long does it need to be? That will be my x. And so what we have then is I'm going to use, this is a 74, I'm going to say opposite over hypotenuse, that's sine. So sine of a 60-degree angle is opposite over hypotenuse, which means x is going to be, how did I get to 74? This is 76. Thank you very much. Okay. X is going to be 76 divided by the sine of 60. And so without using a calculator here, I'm going to say x equals 76 divided by, what's the sine of 60? Well, we have found that many times, but we can also use our special right triangles. So let's just do that again so we get used to it. Here's my 30, here's my 60, 1, 2, radical 3. The sine of a 60 is opposite over hypotenuse. So this is radical 3 over 2, which means I'm going to take 76 times 2 divided by radical 3. And so I get 152 divided by radical 3. This is the exact answer. If you use your calculator, you're going to round and you will not have an exact answer. So if it's a non-calculator problem, you're going to use these values that you can find from your special right triangle for your sines and cosines of those angles. Okay? And, oh, we need to add feet. There we go. That's the end.